Hello, everybody. This is Rick Meyer. I am an owner of Superior Laboratory Services out of the state of Texas. I'm an out-of-state inspector for the State Board of Pharmacy. I'm a voting member for the ISO 14644 Clean Room Standards organizations, and I'm a builder and designer of clean rooms, and also I consult on many different projects in this. With that, I have no conflicts of interest in this presentation. And the things we're going to learn today are review the ways of finding contamination in a washroom or your hand washing area, understanding and testing the objectives and figuring out what happened and how it's happened, and then we're also going to learn how to evaluate those results. So by going in and looking at certain microbial samples, we'll be able to determine where everything is coming from and how to find it. Having said that, first thing we're going to do is Contamination Hunter. That's what we're doing. We're hunting for contamination. The only way to hunt contamination is to dig into the microbial sampling reports, examine how those were put together, what's actually in the report, and after looking at what's in the report, we can do things like determine the origin of the contamination. What does that mean? The origin of the contamination is where does that contamination usually live or breed or grow at? So some of the locations that we can find very simply is, people. It's usually like Staphylococcus epidermis. Then if it's, something in the ground, that'll be brought in by the contaminant person coming into the clean room and changing. Sometimes it's found in air conditioning systems. Sometimes the contaminant is found in the building materials. So looking at that microbial sampling report is going to tell us where the origin of the contamination is coming from and can lead us to where we need to go look to find that source that's causing the contamination. Is the contamination found in the anteroom? If it's found in the anteroom, that's one thing, and probably a good thing. If it's found in the clean room, not a good thing, but we expect to find contamination in the clean room. When I see companies that have shown that they never have a failure of contamination in an anteroom or a hand washing area, I find that nearly impossible to believe, because you're washing your hands in those areas, and when you wash your hands, contaminants are being generated dramatically through the water droplets and skin and debris that's on the skin that is released into the room. It should not move from the anteroom into the clean room. So if you're finding it in the anteroom or the hand washing area, and then you're also finding that same contaminant in the clean room, then something's going on with your gowning procedures or something like that. You got to make sure that when you're doing this, it is in multiple samples. That's what we're talking about, of in the anteroom or the washroom or the gowning room. It goes from those into the clean room, then we know we're doing transference. So we're transferring the contaminant from one room to the other. So that'll also tell you that you may need gowning procedure changes or something like that, so that you don't have that happen again. You need to do surface and air sampling. I found some companies that whenever we went to ask them to do swab testing, they were like, we don't do swabs, we just do touch plates. Well, touch plates aren't going to find certain areas where contaminants hide. Contaminants like to hide in low airflow zones. So where is that? usually it's in the corners of the rooms is where you find that, which is where the bioburden builds up, which is where your cleaning procedures come into play. So all of these things can cause contamination, and then you got to look for how is it happening. And so that's one of the things they're talking about. In the microbial report, it's going to tell us where the sample was taken. As we go through the microbial report, we're also going to look at the certification report because it details the location of where those samples were taken. So then we can actually determine maybe where that is coming from. And that's our starting point of our investigation and hunting down that contamination coming in. First example I have is hand washing sink nightmares. We're going to go through multiple examples of hand washing sinks where I have found issues in the past. And so with this, I'll be able to go over everything that's being said. The location of the failure raises questions. Why is it there and why is it near the sink? It's usually near the sink because sinks are the most contaminating area there is, because you put people that are the largest contaminant we bring into the clean room with the sink where they're cleaning, and contamination should be found very easily. What was the origin of the contaminant? Was the contaminant found in building materials? We don't know. So as we go and look at our report, that's what we're going to find. Okay. How did it get to that location? Testing needs to be conducted on wall penetrations to confirm the seals are intact. One of the things we find a lot of times is that contamination comes in the front of a sink area or around the sink, and that's usually due to wall penetrations or people transferring contaminants while they're washing or scrubbing. And as you scrub, you do produce a lot of, or generate a lot of particulate. And that particulate with the water can lead to no good, okay? What test was performed? Well, when we go out and look and we see that we have a air sample in front of a sink that has a failure, we start looking at how that air, where the air is coming from that's being generated that in front of that sink. The one that I'm talking about here was actually done, and we had a failure of the phone jack that was right above the sink. Why they had a phone jack above the sink, I don't know, but they checked the electrical also near the sink, which shouldn't be near the sink. But it did have a GFI, so everything's good with that. Leakage was not observed until the door was actually opened. When you open a door to a standard build clean room, those wall cavities become positive or negative pressurized. So as you open a door, you may positive pressurize that door, you may negative pressurize that door. May suck the air through the penetration, but when you close the door, it pressurizes it and blows it back out into the room. So you need to do your testing, smoke testing, under dynamic conditions, not under static conditions. If you don't know what static conditions is, static is when nobody's in the room, nobody's moving, no doors are opening, nothing's happening, and we're doing sampling. And we do it with a smoke stick or smoke machine, and we can check and see whether phone jacks or electrical jacks are leaking airflow. The way I prefer to do that is with a coffee can, is the way we used to do it. We used large coffee cans. We cover the entire electrical outlet or phone jack outlet, and we puff smoke into that outlet, and then we open and close the door. As you open and close the door, that's either going to suck that smoke into the hole or blow it out of the hole, depending on whether that jack or that electrical penetration is sealed properly. If it's not sealed properly, what's going to happen is it's going to suck into the wall and then blow back out of the wall. What we found in this application was that the wall jack, the phone jack, had actually been installed after the room was built because they wanted to put a phone in the room. When they put that phone jack in, they did not seal the phone jack. The electrical outlet was sealed, but the phone jack was not sealed. Then every time they opened and closed that door, it blew from the wall cavity, whatever was in the wall cavity, out into the room, and we were finding the contamination. And the contamination was actually normally found in insulation, sheetrock, and other construction build materials. That gave us the reason to look at the wall penetrations, because when you find that your contaminant is normally resides in the walls or your building materials or above the ceiling or something like that, then that's where you got to start your first investigation and start looking at how is this happening and where is it coming from. What we did was we actually checked this phone jack, found it to be leaking, found airflow to be blowing back into the room when you close the door. And so we went in and we sealed, we pulled off the electrical or the phone jack. Once we pulled that phone jack, we sealed the box behind it, closed and sealed it all back together. And once we sealed that all back, we found out that we didn't have any air movement anymore. And then we subsequently did a terminal clean on the hand washing area. And after we did the terminal clean, we did some more microbial air sampling and surface sampling. And by doing both of those, we actually fixed the problem and confirmed that we fixed the problem by microbial sampling it after the fact and doing a terminal clean. So, like I said, we're subsequently sealing this outlet, resampling, and showing the phone jack was the source of the contamination. What did we learn? Even a small add-on to an existing facility can impact the facility's integrity. Our penetration and seal testing should be performed every certification. If you read USP 797 or USP 800, both of them talk about all penetrations shall be sealed, but nobody talks about and nobody adds into there how to test these facilities and how to test the penetrations. And so we've actually come up with a way that we do it, but on this testing here, they also use the same kind of testing that I'm talking about in balancing bureaus and in homes for air leakage in your home around windows and places like that. So a big deal that we have to do to learn, can't add anything to the room without doing some confirmation testing after the fact. If you do any work in the room, you must terminal clean and you must resample and reevaluate what you're doing, or you're going to end up with more contamination. Okay? Retesting is actually required so that you show that there's no contaminants that are there, and that's what we must show that we do, okay? Example number 2. This was one where I had a cart pass-through with HEPA filters in it. It was used a material to move already manufactured or processed materials out of a sterile compounding non-hazardous room. You can't really put a HEPA filter enclosure pass-through in a negative pressure room unless you positive pressure that pass-through and HEPA filter it and confirm that that airflow is moving only one direction, not both directions. And make sure that you can't get any airflow moving from outside in the main pharmacy area to the sterile compounding area, whether it be hazardous or non-hazardous. The FDA has rules that you can't move from a non-classified area to a classified area of less than 2 ISO classifications down. So from non-classified pharmacy area where they're just doing labels and things like this to a compounding area that's ISO 7 is actually 3 levels of drop from ISO 9, ISO 8, ISO 7. So we're down to 3 levels, and you can only do 2 levels of the drop. That's why you can use an ISO 5 hood in an ISO 7 room. That's the guidelines that they set forth. As we were testing this pass-through, we found that, number one, the pass-through had no HEPA filter leakage. So the HEPA filter was leak tested and it came out perfectly fine, no problems at all. No air sample was a failure in the pass-through. No surface sample was found in the pass-through contaminant. So it was passed. Everything looked good. But as we were leaving, we decided to do a visual check and a swab sample of both door sweeps. On pass-throughs, they usually have door sweeps to keep the airflow from moving from one room to another underneath and through the pass-through. So with this one here, they put door sweeps on both sides. With a visual check, we noticed that there looked like dirt on the bottom of the door sweep. A swab sample, just pulling the swab across the bottom underneath the door, found contaminants without even sending them off to the lab. And whenever we sent them to the lab, they were too numerous to count, which means once they get over, 10,000 count, they're just stop counting. But that was on the side that was going to the pharmacy area. You would expect that to happen in an actual non-classified area because they don't have the same cleaning protocols. This is why you have, the terminal cleaning protocols and cleaning procedures that they have in the sterile compounding area. Even though the sterile compounding area had 20 CFUs on the bottom of that door sweep, it was actually staph that was found inside on the bottom of the door sweep. And so that staph probably came from outside, transferred inside and across into the other room as it sat on the floor. And as the cart was wheeled out, it contaminated the sterile side too. So what we ended up doing was removing both of those door sweeps and then changing and modifying the way that the pass-through ventilated. Okay, so even though we had airflow, we had to cross that out and move it so that it didn't come in. The visual inspection is one of the most critical things. When you're when you're testing, I tell people all the time, you got to visually inspect everything. If you look at NSF 49, where they're doing biological safety cabinets, chemotherapy hoods, any type of those hoods, they actually require you to do a site assessment, which is where's the hood located? Is it near a door? Is it near a supply air? Is it near something else? Is it put in an area where it can't get enough air or not enough exhaust? These are the kind of things which a site assessment is going to give you. Visual inspection is very critical, and that's what we recommend that you do. All certifications testing should be done, and you look for out of the view areas is always recommended. What is out of view areas? Okay, you have a door, the door swings against the wall. Go to the back side of that door's frame where the hinges are and swab that back door frame that holds the door and the hinges. This is where contaminants are going to hang out. Most of the problem with large doors and opening them in a large area is that if your door opens all the way and it stays open for over 30 seconds, you're probably going to depressurize the entire room unless it's a very, very large room. The reason for that is that door frame, if it's 3070, which is 3 foot by 7 foot tall door, 3 foot wide, that when you calculate that area, that's 21 square foot. 21 square foot will evacuate a lot of air very quickly. These kind of things can be tested, and I recommend they be tested because of your the loss of pressure is how we get contaminants to transfer from one location to the other. I've proved this before with dry ice and water put in a beaker on the sink in the anteroom of a sterile compounding area, and they had automatic doors that swung open. When they swung open, within 15 to 20 seconds, you could walk into the room with that dry ice out in the hall, the anteroom, and it would actually follow your feet all the way inside the room, and there's where your contamination trail was. And how we found it was by doing that kind of a smoke test. So with the HEPA filter pass-through, the other problem that you have with pass-throughs is that they get hot. So when you're setting yourself up to do this, you need to check and see how long it takes your pass-through to start rising in temperature. We've done some research on that, and what we found was every pass-through, even if it's HEPA filtered, will rise in heat load due to the motors. Even though it's recirculating, that motor produces enough heat to be able to raise the temperature 5 to 7 degrees, and that pulls you out of spec for a clean room when you're at 67 degrees or 66 degrees. And you go to a pass-through and you put it in that pass-through. If you leave it in for over a minute or two, you're going to be out of spec on the temperature. Temperature can affect the efficacy of your APIs and things like that. So watch it very closely. Write you an SOP that says when you get through compounding, you don't just go over and put it inside a pass-through and wait for somebody to walk by to take it. You need to leave it in the clean room, and as you are getting ready to move that material out, you have somebody on the outside ready to take it immediately so that it doesn't stay inside that pass-through. Temperature rise has been noticed in many applications, and so recommendation is to go ahead and make sure those pass-throughs are cleaned constantly. The other place that I find contamination is on the gaskets of the pass-throughs. So pass-through gaskets is another place that you could swab and find issues. We have a third example going on here. And this one was a floor-mounted hand sink. I know you've all seen them. It's a small pedestal with a little small sink and a little gooseneck faucet with foot pedals at the bottom. There were no issues for 3 months, and then failures daily in air sample locations in front of the sink. First, one location, then two, then three. So, with this having been said, their contamination was getting worse and worse and worse. The longer they sampled, the longer they waited, the worse it was getting. So these were all right in front of the pass-through. Not pass-through, I'm sorry, in front of the sink. So this sink is a generator of contaminants. And what we found that we had was something that was growing on sheetrock, or could grow on sheetrock, and was waterborne. Certification company was called. They ran tests, found no problems. Everything looked good. There were no issues at all. But once again, every time they sampled, it was getting worse. Finally, they called me in to do a consult and figure out what was happening. I did a visual inspection and decided that the front opening to the sink, the pedestal, they have a area that you can open that up and on the stand. So when I opened that up, I found water damage and mold growing on the sheetrock. What they had was a small leak in the drain and also on the supply water to the foot pedals. As this water sat there and dripped and drained, the mold got worse and worse. The more it grew, the more CFUs they found and the more contaminant they were finding. And these are issues. What I recommend to all my clients is try to stay away from pedestal sinks, but don't allow, if you have water, you need to know whether that water's leaking or not behind the sink, because you're not going to climb under there and look every day. So my recommendation to people is do wall-mounted sinks, and if you do have to do a pedestal one, leave a gap somewhere where that water can come out. So if there is water that's collecting underneath there, it runs out and you'll see that there's water on the floor. And you'll say, well, I cleaned that up last night. Why is it back here again today? And then you clean it up today and you go back the next day and it's back there again. These are telltale signs that you got a water leak somewhere. And if you let it go, it's going to get bad. These people here had to shut down for 2 weeks as they had to go in and mitigate all of that mold that was growing on their sheetrock wall that was behind the sink that was hidden by the pedestal. This is the same issue you have when you have particle board, laminates, and things like that, that your sinks are set on cabinets. Cabinets in an anteroom or in a washroom, not acceptable. Everything should be non-porous. You may say it's plastic laminate. Well, plastic laminate has cracks where the seams are made. And so that is where water can get into the particle board and where particle board can start to grow. A small particle can move all over the place with just nearly no area needed to be able for it to get through and pass through. Even if you have gaskets like on doors and things like that, particles can get through those. So the answer is, if you get up and you have a pedestal sink, you need to seal it to the floor. But if you do that, you got to leave a small gap there so that if you have a leak, you're going to see that. So sealing things that sometimes are good and other times they're not so good. You got to understand the ramifications of if you block that all in and you have it all hidden behind a wall or behind a sink. Why is that happening all of a sudden? So these things happen. I had another example with a laminate sink that was in a anteroom, and with it, we had mold every day. What they found out was they built the pharmacy on the outside wall of the hospital, and there was a crack in the brick, and it was allowing water to seep in behind the wall, and it got into that sheetrock that was adjacent to the cabinet, and it actually grew through the sheetrock and then started contaminating the cabinets also. So if you've got laminate, they're all have a substrate of wood fiber or something. So my recommendation is get those out of your clean room, get them out of your ante rooms, get them out of your washrooms. You don't need them in any of those locations. I have another example here where sink contamination in air and surface samples. Okay, they had no issues for 6 months, and 6 months they had no problem after construction, and all of a sudden they, with this wall-mounted scrub sink with a knee activated water supply, 6 months after certification and construction had ended, the surface of the sink was contaminated. The next air sample was also contaminated in front of the sink. The next 6 air and surface samples also had failures. The contaminated is linked to building material. They were called me in to once again look out and figure out what was going on. So what did we do? We did the Contamination Hunter program again. We're kind of like hurricane hunters. We're looking for something that tell us what's going on and how it's happening and where it's going. So when I got in there, we noticed that everything was static and there was no problems. And the certification company was in there testing it under static conditions. But every time we did it under dynamic conditions, it failed. These wall-mounted sinks are really nice, the nice stainless steel ones. They have gooseneck, and you can get large sinks there. You don't get water all over the place, but they were having the failures under dynamic conditions, but none under static conditions. We did some smoke testing and everything looked good until the door opened. When you open the door, what happened? We had failures of the sink, and what we did was we were putting smoke around the perimeter of the opening of that front panel. So as we were low volume smoke testing that and opening and closing the door, you could actually see the smoke push out of the way of that little gap where the front panel was on the sink, wall mounted sink. And so as we looked in it, we found that, guess what? There was a huge hole that they had cut in the sheetrock, but it's hidden by the front panel. But it was large enough for a rat or even a small cat to crawl through because they didn't seal any of those penetrations. And when they went to the builder says, well, we decided that the gasket on the front of the sink was sufficient enough to make sure that it wouldn't leak. But they were incorrect because they didn't understand about seals and sealing properly. What we do in my firm is we test every penetration. And that means if you have to open up a wall or a door to be able to get and see what the seals are, you must do that. A lot of people will get escutcheons and things like that and seal around their piping that goes into the walls, but they leave a big gap around there. Sometimes when that happens, we'll actually find sheetrock dust that gets onto the petri dishes, and that also is a telltale sign. And sheetrock dust does harbor contaminants that we can find, that we can look at and we can point to. What I tell them is they must mud that. They should not silicone it. They should mud it. So use the sheetrock mud to seal your electrical boxes to the sheetrock and seal all your penetrations around that. But you can't just seal a escutcheon, because as the air moves in and out from opening and closing doors, those seals will break, especially with silicone going against the sheetrock. That sheetrock is so powdery and porous, over time it's just going to break loose. And so that's why you need to test every 6 months for all of the penetrations in your rooms. If you've got a negative pressure room, you can even put your theatrical smoke into the wall cavity and watch and see if any of it's pulled into the room. I've had it where I found that it didn't go into the positive pressure room, but it did go into the negative pressure room. So if I see it going into the negative pressure room, it tells me, I bet you the positive pressure room is also going to fail. And sure enough, it was once we did additional testing. So your certification company needs to have multiple ways to provide smoke testing. You know, number one, low volume, puffer type, they call them, and high volume, which is your theatrical smoke machine types. And then you can also have super high volume ones like I use for the hazardous drug areas. And we have one that'll produce 50,000 CFM. And we put it in the interstitial up above, and we watch that interstitial up above to see if anything comes into the room from above.
Rick, I have a question for you.
Sure.
And it is about the smoke test. And tell me if you're going to elaborate on that further on, or is this a good place to interrupt about that?
Well, yeah, at this time, I mean, I'm talking about this hole that we found, and this is why I'm trying to explain that you can't just do smoke testing with one little smoke stick. Like, if you read the USP 797, they say, you know, check the smoke inside the hood, and that's your smoke test, and you videotape it, which is a good. It's a good thing to do, and you need to have that, but you'll need to have several other types of smoke machines to be able to look at this. And what you're going to find very soon is that the FDA is going to require you to videotape all of your smoke testing.
Okay. Are we going to talk about that more later?
We can. I can elaborate on what the FDA is talking about doing.
Okay, so I was just, because I was just thinking we should elaborate a little bit on the smoke testing and what it entails, as well as how you perform it. But I don't know if I don't want to interrupt if this is not the best place to stick that in.
Well, we're getting towards the end of the ones that I was telling you about that I had slides on, you know, and so there's others that I can elaborate on and explain too about how contamination happens. And I will tell about one that happened recently here in a minute after I get through with this, but the smoke testing is also going to have to be where you can show that you don't have contaminants rising in the air with your smoke testing procedures. So there's new smoke testing procedures that are being developed right now by IEST and ISPE, and they are looking at introducing them. So when we develop clean rooms and design them, we put low level returns that are, you know, within 6 inches of the floor. We want to put everything on the floor as close to the floor as possible because our HEPA filters are forcing air down. We want a recirculating pattern. And so as you force the air down from above, You want to suck it out on the floor. If you put your low-level returns in the corners, what happens is you actually sweep the floor with those low-level returns. Ours are open bottom plenums. Why do we do an open bottom plenum? Well, we do an open bottom plenum because we get pull from 90 degrees if it's in a corner. If you put it in the center of a wall, you'll get it from 180 degrees. Airflow will be moving towards that low-level return that's open on the bottom. I actually talked to the FDA about this in the training class that I did. And they said, oh, you need a grill on the bottom. I said, no, you don't need a grill, because then you got to get down on your knees and clean that grill. And one of the things I talk about when I do my training classes is, first of all, what doesn't belong in a clean room? And the answer to that question is anything you can't clean. So it seems pretty evident what you need, but it really isn't. It, you know, people, you see them put all kinds of stuff in the clean rooms that they cannot clean. And, you know, if you really want to sit down and clean for days and days, you know, rather than have everything that's easily clean, that's what you need to do.
Do you see that both in 503A and 503Bs? Because I always think that, like, I can see how that could happen in a 503A, but what about the 503Bs?
I do see it.
More tight.
Yeah, I see it in a lot of pharma facilities, and they'll put grills in them. In fact, I talked to one company, and showed him with a visual demonstration on his, while we were having a drink in a bar, and I poked a couple holes in his straw and stuck it back in his drink. And as he was drinking, he found that he couldn't finish his drink because the holes were letting air out. And I said, well, that's the same thing that a grill does on your wall. So if you got a grill that goes up 2 foot, the air is only pulling from the top 2 foot area, not pulling from the bottom at all. And it's very simple. And once I showed it to him, guess what? He changed the design of his facilities that he makes. And he's out of Canada. Mm-hmm. And his grills now are magnetic. So you can pull the grill off, take it out and clean it, bring it back in and put it back in place, which I thought was a good idea. Yeah. You know, but it just shows, if you're going to put something in, make sure that it works. Other people also believe that they can make their grills a damper. Well, grills really aren't dampers. Dampers are volumetric. So you need to reduce the volume of air, which needs to be outside the damper area. If you close off the damper blades, to, you know, thinking you're going to force the air to go or lower the air, you don't lower the air volume, you increase the air velocity. So velocity and volume are two different things. And velocity is what's going to capture and contain contaminants that are on the floor, and that's what we want. We want to make sure that there's no grills. We want to suck it up and pull it at the highest velocity we can pull it without making it whistle. And so these kind of things will help keep you from having contamination in your clean rooms. Bioburden, as I say, go to your house and find where all the dust is. You know where it is? Under your couch and under your bed, because there's no airflow.
Right.
It makes perfect sense if you think about it. You know, why are we doing this? What is going on? In your homes, they put low-level returns in your home. Why? To capture the dust as you walk around the house. You generate dust. Same thing happens in a clean room. As you're walking around, you're generating any particulate that's falling off of you. People alone produce 50,000 particles a minute, you know, if you're not gowned and gloved and masked. In fact, the FDA said, you know, we're the dirtiest thing that goes into a clean room, and that's actually true. People are the problem. And if you watch where contamination happens and where contamination comes from, 99% of the time it comes from people. And how does it come from people? Well, either people aren't gowning properly, or people aren't hand washing properly, or people aren't doing something proper. One of the things that happens is what we call transference. And so we had an issue with a customer a while back, and they were constantly failing and they couldn't figure out what was going on. Well, what they had was one place to sit down and put on your gowns and stuff, and that was it. And what I found was the way to do it is have one where you put on your scrubs, one area to put on your scrubs, And your scrubs can't be worn home, and your scrubs can't be worn to work. They need to be brought with you to work, or they need to be left at work, and then you change that work into those scrubs. Because, you know, your scrubs at home, you got fluffy there at home, you're going to bring fluffiness to the place. And this is how we, you know, eliminate stuff. I did it in an OR and found a doctor sitting down, and then he took off his clothes, and then he put his scrubs on and sat right back down in the same location where he was sitting a minute ago. And so as soon as we switched and made him have two different, a clean and a dirty area to set, all of his, because he caused an infection every time he did the surgery. And so it's called transference, and you're transferring from your this to that. And, you know, I found corn silk, the hair from corn, inside a clean room. You're like, how the heck did that get there? Well, traced it back to an employee that had a farm that went out in the field, you know? So these are the kind of things you look for. These are the kind of things you have to think about. You got to think completely outside the box in this area. One place that I do, they clone roses. And when you go in there, they make you strip down, you know, butt naked, and then they put new clothes on and before you can go in there, because they don't want to contaminate their roses with some other rose or some other rose bug or whatever. And so you got to think the same way when you're doing this. And checking and looking for penetration leaks is a very difficult thing to do if you've never seen it done. You know, if you've never seen it and never performed it, it's difficult to see. I used to show people with a small smoke stick, and I'd get my hand and I would cup it, and I would block the airflow around the, you know, electrical switch, and I'd puff a little smoke and see if I saw any air movement. And then one day I thought about using a coffee can, so I cut the top out of a big coffee can, put it over the top, and pushed it in, and voila, it was very simple. Now I've gone above that. I've gotten clear PVC pipe that's about 10 inches in diameter. We've cut them into, you know, 4-inch deep. You can puff your smoke in there, and what you're doing is isolating that area around the electrical or any penetration. And by isolating it, you're blocking that interference that you get from the airflows that are in the room naturally. So you're really building a little room around that electrical device. And so that's the way that you test them. And same thing as I said with dry ice in a beaker of water. You want to see if you're bringing stuff from your ante room or your gowning room or your cleaning, your hand washing area into the clean room. And you've got electronic doors. What do? Put that dry ice on a beaker of water on top of the sink, and then let it start boiling over. And as it boils over, open the door, see how long it takes till that smoke starts moving into your clean room. Usually you'll find about 30 seconds is the maximum. And if you're moving, it's 10 to 15. And your door is always open for a minute. The other problem with electric doors is that when they open up 100%. If you make it where your doors always swing into the room, you backing into the room, then guess what? As you go into the room and you get half or a quarter of the way in, you're turning and moving into the room, and that door doesn't open but a third of the way. So take a third of 21 square foot, and that's what you're getting, which is more like 7 square foot. That's manageable by airflow volumetric controls. And so that's where we keep contaminants from coming out or coming in or migrating in. I have all kinds of little tricks of the trade I show my people. You know, if we have pressurization issues, and we've been to 3 different large 503B facilities recently, and every one of them, the air balancer has been there for 3 months and they can't get it balanced. And they bring us in and a week later, we're done. And they're going, how did you do it? I said, well, we don't care what your numbers say, because when you're doing air balancing, you must follow air balancing guidelines. We think outside air balancing guidelines. So we will do something like, let's say you're at 0.07 inches of pressure in the room, and we need to be at 0.04. We open the door, crack the door open until we get to 0.04. We measure that opening, and that's the calculation of how many square foot we need to bring into the room. And so there's simple ways to make this thing happen, but air balancers are bound by the engineer's guidelines. So the engineer says, I got 600 CFM in this filter. They're, by God, going to put 600 CFM whether it works or not. They say, well, the engineer needs to come and change it, not us. And we're not bound by that. But we go in and we get it all done and everything works and everything. And we, also smoke test. It's just like whenever we do design build, and we're designing it, we're consulting on it, we're designing it, we're building it, and then we're testing it afterwards. What is my rule for if I test your facility like that? My rule is that you must watch every test be performed, and you must be explained to every test was performed and what the instrumentation does and what it's telling you. So if I'm explaining to you how the mass photometer works and how the leak test works, and you see a challenge being put in and you see the leak test being done, in fact, I even let the client do it so they can see what it's really like to do what we do. This gives your clients confidence that they're doing it. When they get through, they check off every test that was performed. Okay, so validation of your operation is very critical. Having talked about these hand washing sinks and everything like that, these are the kind of things that I find constantly people are failing in the hand washing sinks. It always happens. And if not there, then what's happening is they're transferring it from the hand washing area to the other area by doors that swing open and stay open too long. So those are the things that are going on. Okay.
Rick, thanks. That's, as always, talking to you is just so much information. I do have one question, and that is, how does the origin of contaminants affect your outcome? I mean,
well, the origin of your contamination, knowing where it's coming from, will help you find that contaminant, or at least let you direct you where you need to start looking. And once you do that, if you find that contaminant, then removing that contaminant is the other factor. So, if it's in your sheetrock, it's got to be removed and it's got to be taken out. You can, in certain cases, seal those penetrations and come out okay. But if you're not, then you can't seal it, then you've got to remediate it. So those are the two options you have. So your outcomes will be determined by how far you have to go in and how far you have to do that. My recommendation to everybody is, if you're going to be doing remediation, buy you a negative air machine so you don't shut down the rest of their facility if you can do it while you're remediating.
Seems a logical thing or a sensible thing to do.
Yeah, we did one and added an extra manufacturing line in a pharmaceutical facility while they were manufacturing right beside us. And all we did was put a particle counter on the other side where they were manufacturing to monitor what was going on as we did construction on the other side, and sucked it negative with a negative air machine. And so it seems simple, but a lot of people don't understand simple. If you go to hospitals, they're all now got all these really nice containment areas where they have zippers and everything for the doorways. And I think it's a little overkill. But, somebody's got to make a living selling something.
Okay. All right, great. You said this is the last slide. So do you have any parting thoughts, parting comments?
No, but, as I did, the question they have, what report do you need to see to start your investigation? I say the certification report, which has the microbial report in it. The certification report is critical because you need it so that you can find out what location that microbial sample failure was located at, so that you can go look, like if it's in front of the sink. Now that gives us direction exactly where to look to find it. If it's in the anteroom and it's, coming from corn silk, then, it's probably not coming from inside the clean room anywhere. It's coming from outside the clean room and somebody dragging it in on their feet. or on whatever else, you know. So there's ways that you need to start your investigations and look at those investigations. And if you find penetrations that are sealing or failing, you need to really look at those penetrations and test them properly. Like for the drain lines, I actually use a coffee creamer jar, the plastic ones.
Mhm.
I cut the bottom out of it, and then I slit it up the side, and then I can open it up and wrap it around the piping that goes through the wall to see if it's leaking. Me and my coffee, I guess my coffee can and my coffee creamers,
I was gonna say,
you know,
you're very
I'm
creative.
trying to recycle. I'm recycling. That's it.
Excellent. All righty then. Well, thank you so much. We really appreciate you doing this. And if
Sure.
anyone has any questions, can they reach out to you?
Absolutely. Anytime.
All right, great. All right. Thanks very much. Have a great day.
All right. You too.
All right. Bye.
Bye.